Hello, and welcome to Energy Auditing 101, Common System Types. This short presentation is brought to you by the Oregon Housing and Community Services Multifamily Energy Program. It is the third and final of the three modules that we will be presenting on the energy auditing process in multifamily buildings. In this module, we will be discussing common system types seen in multifamily buildings in Oregon. Some of the information given on slides will not be discussed, but is available as a future resource. The first type of system that we'll be looking at is lighting. Lighting comes in several levels of efficiency. Incandescent lights are the traditional bulb type and are the least efficient, with much of their energy being turned into heat rather than light. HID, or high-intensity discharge lights, are somewhat more efficient and are typically only used in high-power situations such as floodlights. Fluorescent lights have a large variety of form factors as seen here and may be compact or standard size. These were the most efficient form of lighting until the advent of LEDs. LED lighting is now the standard for efficient lighting. There are a wide variety of form factors for both LED bulbs and hardwired fixtures, although this program is only able to offer incentives for installed hardwired fixtures, not LED bulbs. In addition to being more energy efficient than fluorescent lights, LEDs offer longer runtimes, reducing maintenance, and are available in a variety of color temperatures. Controls are also crucial for lighting savings in common area or exterior applications. Exterior lighting should be controlled by photocells or atomic clocks, while motion activation may be preferable in interior spaces. For spaces that should maintain a minimum level of lighting, such as hallways or garages, bi-level LED fixtures can dim down to a pre-assigned set point, typically around 20% power, until they sense movement, then turn up to 100%. Particularly in more moderate climates, hot water is a very substantial energy use in multifamily buildings. Central water heaters are uncommon in this region and are typically gas-fired systems. In buildings that do have these systems, however, the tank may be a part of the water heater or separate from the boiler. In either situation, a condensing water heater is a very efficient option and can bring the efficiency of the system from approximately 80% to over 95%. The majority of the systems here are in-unit electric systems. Standard tank-type electric resistance water heaters can be replaced with heat pump water heaters or tankless water heaters. Heat pump water heaters use heat from the air to heat the water and are 3 to 4 times as efficient as electric resistance. However, because the heat pump system is situated on top of the tank, they require somewhat more space, and they require airflow. This airflow may be achieved with a louvered door directly drawing the cooled air out of the space. Tankless water heaters do not need to keep a reservoir of heated water and so can be much more efficient in units where hot water is only called for rarely. However, because they must deliver hot water on demand, they require a breaker that can handle the high load. In buildings where natural gas water heaters are installed in the units, an Energy Star or tankless water heater may be viable, efficient options. As with electric tankless water heaters, gas tankless water heaters have high load requirements and so will often require a larger gas line than what was previously installed. Additional hot water savings may be attained by minimizing the hot water use through low-flow fixtures. Research has gone into these in recent years so that they are more enjoyable to use. However, if fixtures are installed that don't deliver enough water for their application, such as 0.5 gallon per minute kitchen aerators, it is likely that tenants will complain or remove the fixtures themselves, negating their purpose. Additionally, in central systems, a recirculation pump will typically be installed, which often has no controls limiting its operation. Heat is lost from hot water moving through uninsulated pipes in addition to the pump energy. The photos here are various control strategies to minimize how frequently the pump runs. From left to right, there are aquastats, which shut the pump off if the water in the recirc loop is already hot, and demand control systems, which do this in addition to sensing if occupants are using hot water. Finally, a variable speed pump will have these features and be able to adjust its speed rather than shutting off completely, which can help minimize crossover. Here you can see an example of an existing central tank-type water heater in the background, with a recirculation pump that is being controlled by an aquastat attached to the incoming hot water line. Having an effective building envelope is crucial to reducing HVAC usage in buildings. Building envelopes may be improved by increasing the insulation or reducing the uncontrolled air movement through the envelope. Insulation is available in bats, shown in the photo to the left, loose fill on the right, or rigid, which are hard boards typically made of foam, although other materials may be available. Bat insulation is typically fiberglass, while loose fill insulation may be fiberglass or cellulose. Air gaps in the building envelope, typically at seams and penetrations, allow conditioned air to flow out while unconditioned and potentially unhealthy air comes in. When insulation is added or replaced is an ideal time to work on reducing the air leakage through the building, which can be measured using a blower door test. Leakage points can sometimes be visible based on dark, dirty marks on existing insulation where air has moved through, which can be seen in both photos here. Insulation may be added to all thermal boundaries of a building. In the attic, bat or loose fill insulation is typically used, or a rigid board may be attached to the underside of the roof to extend the thermal boundary out to include the attic space. Typically, bat insulation is installed in crawl spaces, but it must be affixed so that it won't sag away from the underside of the floor over time. Walls may be insulated with bats if the wall sheathing is being removed, or have loose fill insulation added through a drill and fill process, in which holes are drilled between each set of studs and insulation piped in. EIFS, or exterior installation finishing systems, may also be added on the exterior of the building using rigid insulation. Windows can be replaced with dual or triple pane windows with low E coatings, which will provide substantially better insulative properties and air sealing than single pane windows. However, from a cost versus savings perspective, the value ratio of new windows typically won't be nearly as high as insulation due to the cost of window installation. Heating, ventilation, and air conditioning, or HVAC, may be provided by a wide variety of systems and fuel sources. In Oregon, the most common systems will be electric, and so those are what we will be focusing on. Electric resistance heating systems can be fan-driven or rely on natural convection. Baseboards use natural convection to move hot air over a series of warmed fins, similar to the hydronic system shown here. Fan-powered systems may be ductless, as with the wall heater shown, also known as a cadet heater, or they may use a forced air unit blowing heated air through ductwork. These systems will look similar to the furnace shown here, and can also be connected with an outdoor compressor for air conditioning. Alternatively, air conditioning may be provided via a package terminal air conditioner, or PTAC, which comes through the wall and requires no ducting. For electric systems, replacement HVAC should always be heat pumps, which deliver both heating and cooling. This program does not support fuel switching, so for non-electric heating, other types of systems are available. As with water heaters, heat pumps are multiple times as efficient as heating for electric resistance. Air conditioning is provided through the same mechanism, and efficiencies are similar, although with new systems, the heat pump will be somewhat more efficient than traditional air conditioners. Heat pumps are available as package terminal units, outdoor compressors of the same form factor as air conditioning units, or as mini splits, shown here. These still have outdoor compressors, but use individual head units to deliver conditioned air and require no ductwork. As a result, they are typically the most efficient option. Ventilation is also crucial to take consideration of. Existing ventilation may not be present at all or may exist as manual fans in bathrooms and kitchens only. This program incentivizes bathroom fans with humidistats to control how frequently they run. To improve indoor health, a balanced ventilation system is recommended. This involves adding supply fans so that both incoming and outgoing air are controlled. This prevents air from becoming stagnant inside of the building or being dragged in from uncontrolled areas via a depressurized building caused by outgoing fans only. Ventilation is something of a balancing act, however, between energy efficiency and health. To maximize efficiency, we want minimal unconditioned air entering the building and minimal fan use. However, to maximize health, we want to move air through the building and control and filter the source of incoming air. Heat recovery ventilation units help minimize this problem by running the incoming and outgoing air streams past one another and transferring heat between them, so that incoming air is partially conditioned already. The final large energy user we'll be discussing are appliances. Refrigerators and dishwashers are recommended to be updated to Energy Star models. Washing machines are also recommended for updated models, although rated by Energy Star or on the CEE tier scale. Front-loading washers typically provide savings over top-loading models of 20 to 30% on water and energy use. There are a few efficient dryers on the market, but heat pump dryers are on their way and it's worth keeping an eye out for them. Finally, if the existing stoves are electric, it is worth looking into induction models. These use electromagnets to directly heat the pan rather than the surface of the stove, which makes them more efficient since there is no wasted heat. They are also safer since the surface stays cool. Finally, the energy auditor should inspect the electrical systems of the buildings and units that they enter. This will give clues as to what types of systems will be manageable and if work will need to be done on the panel to allow for the systems being recommended. For example, the main unit breaker on the left is only 50 amps, which would not be sufficient to support large load electrical systems if the owner wanted to install induction stoves and/or tankless electric water heaters. It is also important to keep an eye out for traces of old wiring. If knob and tube wiring is visible in the attic, it is unlikely to be in use, but it may still be connected to the system and will need to be removed before insulation is added due to risks of fire. This has been the final of 3 modules on Energy Auditing 101 in multifamily buildings. We hope you have enjoyed this presentation, and if you haven't already, we'll watch the previous 2 modules. In these, we discussed the purpose and protocols of energy audits, their place in the Oregon Multifamily Energy Program, and the process of carrying out an energy audit. Thank you, and we hope you have enjoyed this and the other modules.